Hey guys, welcome back to another new video of Pranav's lecture. So in this video, we will learn about Prim's algo. So we have already discussed about Kruskal's algo for MST. So like this, Prim's algo is also a greedy algorithm. This algorithm always starts with a single node and moves through several adjacent nodes in order to explore all of the connected edges among the way. Okay. So now we have discussed about Prim's algo, how it is works. So how the Prim's algo, how Prim's algo works. Here 3 to 4 steps are there. By the help of this step, we can calculate how we can find out the minimum spanning tree by the Prim's algo. Okay, first step number 1, what saying? Determining the arbitrary vertex of the starting vertex of a minimum spanning tree. To determine an arbitrary vertex as the starting vertex of the MST, minimum spanning tree. Okay, then come to the step number 2. The step number 2 is what? We can find out the edges connecting any tree vertex with the starting vertex, means the adjacent vertex. Find out the edges connecting any tree vertex with the starting node that we have selected. Okay, clear? Then come to step number 3. The step number 3 says that we can find the minimum. Okay, find the minimum among these edges. Find out the minimum of these edges. Then step number 4. Then step number 4 says add the chosen edges to the MST. If it does not, then simply return and exit. Okay, so these are the 4 steps that we can follow for the Prim's algo. Okay, so now by an example I can understand how the algorithm works. So let us draw a graph. By the help of the graph we can find out the minimum spanning tree. Okay, so here the graph is a to b, a to b is weight is 1, b to d, the weight is 4, d to f, the weight is 1, f to e, the weight is 5, e to c, the weight is 4, a to c, the weight is 6, b to c, the weight is 3, c to e already done, c to d, the weight is 2, d to e, the weight is 3. Now b to f, the weight is 2, and f to c, this is f to c, the weight is 7. So this is our undirected weighted graph. Okay, so first we see if any self loop are there, then simply we can exit this node, and if any parallel edges are there, then we also remove these edges. Okay, so here there are any no cases where the self loop is present or parallel edges are there, so we cannot want to remove anything. Okay, so simply we start our process. So step 1 is what? We choose any node as a starting vertex of our graph. Okay, so I prefer that A in alphabetical order we can choose. So step 1, step 1, step number 1. What? Now choose starting vertex. Here we choose starting vertex as a. So like draw this a. Okay, so here we choose the starting vertex as a. So here the adjacent edges are there, a from node a. Here a to b is 1, a to c is 1. Okay, so two edges are there. So here find out the minimum weightage. The minimum weightage here 1. So we simply draw a to b. So here what we do? Step 1, a to b, the weight is 1, and the remaining weight is here what? 6. So simply we can write in back side 6 is remaining. Step number 2. Now we reach the p position, then simply see the graph b. The adjacent here, what are the adjacent edges? B to d1, b to f2, b to another one is b to c 3. So here 3 edges are there, 3, then the weight corresponding weight are 4, 2, 3. Here what is 6 is remaining, and 4, 2, 3. So here minimum is 2 means b to f. Here the weight is 2. So simply draw a to b1 and b to, then b to f, b to f. Here the weight is 2. Now we will in the position f. So see the graph in the position f. Here the adjacent nodes are what? E, D and C, and the corresponding weight are 7, 5 and 1. 7, 5, 1. So here already the remaining are 6, 4, 3 and now 7, what? 7, 5, 1. 7, 5, 1. So here what is the minimum? 1. 1 is the minimum. So simply draw what? Save f to d, 1, f to d. So here draw in a step number, this is step number 3. Okay, a to b 1, b to f 2, f to d 1, f to d 1, f to d 1. Okay, understand? Yes or no? Okay, so this is 1. So now step number 4. Step 4. Now we reach the position at D. So see the adjacent of D. What are they? And the corresponding weight are 4, 2, 3, 1. 1 is already done. Then we left this 4, 2, 3. So here the remaining nodes are also 6, 4, 3, 7, 5. What? 6, 4, 3, 7, 5, and the now come 4, 2, 3. 4, 2, 3. Now here what is the minimum? 2. 2 minimum. Okay. 2 means D to C. Okay, simply we draw A to B1, B to F2, F to D1 and D to C. D to C2. Now we reach the position C. So simply C again. What are the adjacent nodes? A, C to A, C to B, C to D, C to E, and the corresponding weight are 6, 3, 2, 4, 7. So I cannot write in now. So in step number 4 I directly do this. Step number 5, sorry. So here what we can choose, what is the minimum? Where? 2, in the position 2 it is the minimum, but we already do this. Okay, so next minimum is what? 4. Yes or no? Yes. So C2 minimum we can choose C to E. Okay, C to E. So simply draw A to B1, B to F2, F to D1, D to C2, C to E. 4. Okay, clear? Then we in step number 5. Now we have reached at the position E. Now we reach at the position E. Okay, sorry, here the node is not correct, because I say sorry, because here see, when we reach at the position C, okay, means C, so here the node we have selected for, but remaining are also there, so remaining in this remaining part here 3 is also present. Okay, so as here 3 is already present, so we have to draw this node, not the C to E. Okay, so here means in this part we return to the D node and simply draw D to E, D to E, because D to E 3, D to E, and the weight is 3. Okay, so this is correct. Now D to E, so we have already E to F, and now this is our final minimum spanning tree, because we have already visited all the nodes of this graph, because see, and see here A B C D E F. Okay, all the nodes we have already visited, so this is our minimum spanning tree from that given graph. And here the how many vertices are there here? 1 2 3 4 5 6 7 7 vertices are there. And how many edges are there? N minus 1 number of edges. So 1 2 3 4 5. Okay, okay, clear. In the sixth number of vertex, and we find out here the 5 number of edges, means it satisfies the condition, the formula n minus 1 number of edges. Okay, so here now the total cost is how much? The total cost, total cost. So here simply we can add the 3 2 1 2 1, so the total cost will be 9. Okay, so thank you. If this video is informative and valuable for you, so please like and share and comment in this video. Thank you. Jai Jagannath.